Hello Unite and welcome back to Math and Magic. Today we're continuing in our topic of linear relationship, and what we're doing in this lesson is we're looking at a few special linear relationships which only have one intercept. And so our three success criteria today are: we want to graph lines in the form of x is equal to a, we want to graph lines in the form of y is equal to b, and the final one, we want to graph lines in the form of y is equal to mx. So that's the three things we want to be able to do by the end of today. So to start off with, let's just do a quick summary of what we covered in the last lesson. Now, in the last lesson, we talked about finding intercept of linear relationship, and we also talked about this in our first lesson of this topic. And so what we talked about was any linear relationship, well, actually, most linear relationships will have two intercepts. You've got your x-intercept, which is where your line touches the x-axis, and the condition for us to have an x-intercept is we want to sub in y is equal to 0. And the other intercept that we have is our y-intercept. And so our y-intercept, we do the opposite and we subbed in x is equal to 0. And so we found the intercept for a few different linear relationships, and we actually practiced substituting x is equal to 0 and y is equal to 0 into our linear relationship rule. And then we found our intercepts. And the thing that we did after we did this was we were able to plot our linear relationship using these intercepts. So once we had found these intercepts, what we could do was we could go, okay, I have my, let me get my axes out. I have my Cartesian plane, and I have my I've got my y and my x, and I've got my two intercepts. I have one intercept here, for example, and I have another intercept. My y-intercept is up here. Let me try that again. And my x-intercept is down here. And once I've done that, I can just draw a straight line through the two of them. And then we've drawn our linear relationship. And it was we found that this method of drawing a linear relationship is a lot quicker than actually drawing it by using a table of values. And so by doing this way, we can actually draw our linear relationship a lot quicker. What we are covering today is there's a few different special linear relationships where there's only one intercept instead of having two intercepts like these ones here. So we're going to have a look at these linear relationships with only one intercept. So let's start off with our first one. Our first one is if you ever see an equation where it says x is equal to a. So for example, I have x is equal to 1. Now let me just draw up my Cartesian plane again here. Now if I have my Cartesian plane that looks like, let me try this again. This, let's say we have a few values on here. We've got x and we've got y, and let's say 1 is here, -1 is here, 1 is here, 1 is there, and -1 is here. What we want to do is we want to find a few points where x is equal to 1, where we have an x coordinate being equal to 1. So if you ever look at my Cartesian plane, well, there's quite a few spots where x is equal to 1. The first one that you might be thinking of is actually this point over here. When you see x is equal to 1, that can refer to our x-intercept at 1. So we can have that point there. But there's more than that point that has an x coordinate of 1. If you have a look at this point here, it has a coordinate of 1, 1. The x value of this coordinate is 1. And so this point also has an x value of 1. But we've also got more points than that. We've also got this point down here. This point, if you remember from our coordinates, x coordinate comes first and y coordinate comes second. This one has a coordinate of 1, -1. So here, this point also has an x value of 1. And so here, if you're starting to notice there's this pattern, what we can do is we can draw a straight line, vertical straight line, that goes down here through 1, and this is how we draw x is equal to 1. So if you ever get given a linear relationship where it's just x is equal to a number, it's just going to be a vertical line. So if you have a look at the notes on the right hand side, this is a line which is parallel to the y-axis. So notice the y-axis is this line over here, and all my vertical lines are going to be parallel. So this is a vertical line, and it is parallel to the y-axis. Okay, and it has an x-intercept at a. Depends on what the a value is. What we're going to do is we're just going to change that depending on the question. So if you ever see a linear relationship in the form of x is equal to a, that just means you're plotting a straight vertical line. Okay, so that's our first special linear relationship which only has one intercept. The next one that we're going to have a look at is y is equal to b. So if you ever see a linear relationship where you have y is equal to a number, so for example, I've written down here y is equal to 1, and hopefully, just by looking at the way that we did the previous one, hopefully you can try, kind of like identify how we actually can do this. So I'm just going to draw up my Cartesian plane again. And I realized it's blue and I don't want blue. Okay, here we go. This one's a little bit bigger. Okay, so I'm going to include a few points. X, Y. We've got the X values along here. We've got our Y along here. Okay, now what we're trying to look for is any points on my Cartesian plane which have a y value of 1. Now the quick and easy one that you would have noticed is that we can put a point here immediately at the y-intercept. The y-intercept being 1. The y-axis, actually. I should have said that the first time. The y-axis. At this point, the y-coordinate, the y value is 1. So this point here is 0, 1, and so the y value is 1. But just like we noticed in the previous question, there's a whole bunch of other points on my Cartesian plane which also have a y value of 1. So for example, if you move to the right 1 unit, so if I move over here, this point over here, this point has a coordinate of x coordinate 1, y coordinate 1. And so here, this one, it also has a y coordinate of 1. And if I went to the left from my starting point there, we'd also have another point here. This has a coordinate of -1, 1. It also has a y coordinate of 1. And so here, hopefully you're going to notice that instead of having a vertical line, when we see an equation where it says y is equal to a number, so y is equal to b, whether that be 1, 2, 3, -3, -2, -1, it's going to form a horizontal line like this. And so this is my second example of a linear relationship which only has one intercept. So notice here, we only have one intercept at the y-axis, and over here we only had one intercept at the x-axis for our previous example. Now these are horizontal lines. And if you notice from the pattern, our vertical lines were parallel to our y-axis, and so our horizontal lines are going to be parallel to our x-axis. So here, this is going to be parallel to my x-axis, and the y-intercept is going to be at b, whatever the value of b happens to be. I said a lot of b's in that last sentence now, didn't I? Okay, so the first two special types of linear relationships which only have one intercept is if you ever see x is equal to a, x is equal to a number, and those give us our vertical lines. And the second one is if we see y is equal to b. So a second, here we've got horizontal lines where at the value of b. So let's have a go at a couple of examples where we need to graph our vertical and horizontal lines. So here's what the following questions are. Example 1. Sketch a graph of the following lines. So we want to sketch these following linear relationships, and they're going to be vertical or horizontal lines. So let's have a look at this first one. Y is equal to 3. So that's my first one here. I'm just going to pull out my Cartesian plane. Now, unfortunately, you don't have the... you might not be as lucky to be able to pull out a Cartesian plane just out of nowhere like that. It's a nice little trick. Here we've got our y and our x-axis. Now, y is equal to 3. If I ever see anything in the form y is equal to a number, that just tells me it's going to be a horizontal line. And so what I'm going to do is I'm going to find where y would be equal to 3. So having a look at my Cartesian plane, I should probably put in a few points. Here, one. You could put points like this. Actually, I'm going to do it another way. What we can do is we can just go, okay, I'm going to put in my point here and say that this is where 3 is. And all I need to do is I just need to draw a horizontal line at that value of 3. And so this line here is y is equal to 3. So if you ever see an equation where it says y is equal to 3 and we have to plot it on a Cartesian plane, we're just drawing horizontal lines. Horizontal lines. Okay, next example. X is equal to -4. X is equal to -4. So let me pull out my Cartesian plane again. Like this. So here I've got my y, and my x. Now x is equal to -4. If you ever see a rule or a linear relationship where we need to draw x is equal to a number on a Cartesian plane, those will give us vertical lines. Vertical lines. And so what we want to do is just plot on our Cartesian plane where -4 would be. Now on my Cartesian plane, -4 would be on the left-hand side of 0. So here, I'm going to put a dash at wherever -4 is. Now, with the Cartesian plane, notice here, I have actually got a grid, and you don't actually need to keep going, go 1, 2, 3, 4, and so on. As long as your graph is even, and if you only got 1 point, you don't actually need to worry about that too much. I'm hoping I don't erase my numbers, as long as it's evenly scaled. So here, I'm just going to put in a -4 here. I'm just going to draw a vertical line at where x is equal to -4. So here, there we go. And you can tell that I'm very good at hitting the mark there. Let me try that again. Yeah, there we go. A little bit better. So this is how we draw x is equal to -4. And so these are our first two examples of linear relationships with only one intercept. X is equal to a number or y is equal to a number if we need to plot them on a Cartesian plane. If it's x is equal to a number, it's just going to be a vertical line, like this example here. If it's y is equal to a number, it's going to be a horizontal line, like the first example in A. Okay, so those are our first two special linear relationships which only have one intercept. We've also got another type of linear relationship which only has one intercept, and that is if you ever see the equation y is equal to mx, where m is just some random number that you don't know. So for example here, I've got y is equal to 2x. That's an example that we've got. Now, some of you may have actually plotted this during our first lesson when we were creating a table of values. What I'm actually going to do is I'm going to do this one, but I'm going to create a table of values. So here, what I'm going to do is I'm going to go create my table of values. Oh, let me make it a little bit neater. I'm going to create a table of values, x and y. I'm going to go -2. Oh, let's make it a little bit easier. -1, 0, and 1. And if you remember from when we were creating our table of values, what we do is we substitute these values into our rules. So for example, this first box, I'm going to substitute x is equal to -1. So I'm going to go y is equal to 2 times -1, which gives me -2. Okay, the next box, we substitute x is equal to 0. If we substitute 0, 2 times 0, that gives me 0. And the final one, I substitute x is equal to 1. When I do 2 times 1, that gives me 2. And so now that we've got this, we can plot this on our Cartesian plane by reading each one of these columns as a coordinate. So here, the first column, that's just coordinate of -1, -2. We've got 0, 0, and 1, 2. And so we can plot this on our Cartesian plane. So let's actually go and do that. So here, there we go. I've got my Cartesian plane here. Y, oh, what happened here? Why did it go lower than I needed to? Let me try that again. Shape, Cartesian plane. There we go. I've got Y, I've got X. And so we're going to plot these points. So we've got, let me put in a few values as well, just to make it easier. 1, 2, -1, -2, 1, 2, -1, -2. And so the points were -1, -2, 0, 0, and 1, 2. And so our linear relationship for this one would look like this. Let's just draw a line through that. Okay. So that's what this one would look like. Now, as you notice, this line also only has one intercept. It has an intercept at the origin. So the x-intercept for this line is at 0. And the y-intercept at this line is also at 0. And so this is another example of one of those special linear relationships which only have one intercept. And so for this particular type of linear relationship where you just see y is equal to m times x, so a number times x, what we need to do is we need to actually include one more point on our linear relationship to show that it is this specific one. Because if you just draw any line that goes through the origin, you don't know which one it could be. It could be y is equal to 2x. It could be y is equal to 3x. It could be y is equal to 100x. But you want to be specific and show that it is the one that you have. And so underneath, I've got a few steps that you can follow that will show your specific linear relationship is the one that you're drawing. So here, let's have a look at this one. The steps I have. If you are sketching the graph y is equal to mx, what we're going to do, the first step is plot the point 0, 0. What we want to do is include the origin. So we want to put a point at the origin, 0, 0, that one intercept that we have. Then after you've done this, all you need to do for the second step is substitute x is equal to 1. Now I recommend doing 1 because 1 is quite easy to substitute, or you can substitute any other value than 0. You could pick any random number and you can get, that allows us to get a second point. You could substitute, for example, 100. You could substitute 2000. You could substitute 9001. You can substitute any number that you want. As long as you substitute it in and you can get a y value out and you can plot a second point on your Cartesian plane. Then once you've done that, draw a line through the 2 points and then you've shown, you've sketched your graph y is equal to mx. So let's have a go at doing this. Here in example 2, we want to sketch the graph y is equal to negative 3x. So notice here, this is in the same form as y is equal to mx. We just have y on its by its own on the left. We've got x at the end and nothing else. And we've got we're multiplying x with a number. Here it happens to be negative 3. So if we're graphing this, what we need to do is I'm going to draw my Cartesian plane. Here we go, my Cartesian plane. We've got y and x. I'm going to put in a dot at the origin, 0, 0. My first step, put a dot at the origin, 0, 0, because that is the intercept that we're going to pass through for this particular line. Then after we've done this, we're going to substitute another point. We're going to substitute a value of x into my rule. So here, the easy one to do is x is equal to 1. So I'm going to go sub x is equal to 1. So y is going to be equal to, because my rule is negative 3x, it's just going to be negative 3 times 1. Okay, negative 3 times 1 just gives me negative 3. And so what this tells me is I have another point on my line that I can draw. This point is x is equal to 1, y is equal to negative 3, or just 1, negative 3. So I'm going to go on my Cartesian. I'm going to go onto my Cartesian plane. I'm going to put in a few lines here. 1, 2, 3, 1, 2, 3, negative 1, negative 2, negative 3, and we've got negative 1, negative 2, and negative 3. I'm just going to plot in my second point of 1, negative 3. So 1, negative 3 is down here, and now I've got 2 points. And so once I've got these 2 points, I can just draw a line through them. So here, this is my line. If I can get this to line up. There we go. And so, now that I've done that, this is how I've sketched y is equal to negative 3x. And so there we go. So if we're sketching any linear relationship in the form y is equal to m times x, so a random number times x, what we need to do is firstly plot on the origin. And then after you plot on the origin, substitute x is equal to 1 or any other value and get a second point, plot that on the Cartesian plane, and then draw a line through it. So those are the 3 special linear relationships which only have one intercept. The first one was x is equal to a number, and that gave us a vertical line that was parallel to our y-axis. The second one was y is equal to b, where we had a horizontal line which had an intercept of b. And the final one was y is equal to mx, which went through the origin, and then we had to substitute a second point to actually help us find that specific sketch that specific linear relationship. So, once again, if there's any questions that you have, go back and have a look at those relevant sections in this video. And if you've got any questions, feel free to send me a message via email or on Google Classroom. And I will see you guys next lesson. I hope you're staying safe, Year 9s, and I'll see you then. Bye.